Greetings, chemistry students. Today we're going to reach the conclusion on chemical equilibrium by talking about something called Le Chatelier's principle. And what Le Chatelier's principle says is that if you have a system at equilibrium and you apply some sort of stress or disturbance to that equilibrium, then the reaction will shift to either the reactants or the product side in order to minimize that stress, or in other words, to try and undo what you just did. So, for instance, if you increase the pressure on a system at equilibrium, then the reaction will run to whichever side has the least amount of gas molecules, because that would have the effect of reducing the pressure in the container. If you decrease the pressure by making the container larger, then it would do the opposite. It would shift to whichever side has the most gas molecules. If you heat a reaction, it shifts to whichever side would remove the heat. So for an exothermic reaction that as it goes towards the products produces heat, then if you heat the reaction up, it's going to shift the opposite direction to absorb that heat. And vice versa. If you cool it down, it would shift to whichever side would produce more heat. If you add a reactant, it would shift to the product side to try to produce more products. If you remove a reactant, it would shift back to the reactant side to try to make more of that reactant. We're going to take a look at an example real quick. Yesterday, you saw a demonstration with nitrogen dioxide, which is a brown gas, and dinitrogen tetroxide, which is colorless. And I was able to manipulate this equilibrium position by changing the temperature. Now, this reaction is exothermic, it produces heat. So, if we were to cool this reaction down, then the reaction is going to shift towards the product side and become more colorless as it tries to produce more heat and bring the temperature back up. If we heat this system up at equilibrium, then it's going to shift towards the reactant side to try and absorb that heat and produce more nitrogen dioxide and turn brown. And that's what we saw, was that as we uh, cooled this down, the vessel became more colorless, and as we heated it up, it became a darker brown color. Now, we could also shift this equilibrium. For instance, if we increase the pressure on this container, well, there's two gas molecules on the left and only one on the right. So this reaction would proceed from reactants to products. We would make more N2O4 and less nitrogen dioxide to try to bring the pressure back down. If we increase the pressure in the container, the reaction would run the opposite direction to try and produce more gas molecules, because as you go from N2O4 to NO2, you double the gas molecules, basically double the pressure. The reaction would run in reverse towards the reactant side to try to bring the pressure back up. If I were to dump in a whole bunch of excess NO2, then the reaction would proceed to the product side to try to bring the amount of NO2 down, and as a result, the N2O4 would go back up.